Okay, so now we know how to add vectors together by converting the vector into the x and y components, then adding the components together to get the sum of the two. So the thing is, our new vector is in x and y component notation. So what if we want to go back to our magnitude and angle description? How do we get back to that? Well, first let's look at defining the magnitude. So we have the x component of our vector here. So this is a of x, our x component. And then we have a of y, so that's this or this. So that is the y component. And so, well, we notice that this makes a right angle, right? So this means that the x and y components make two sides of a right triangle, and the third side is the hypotenuse. So that means we can use the Pythagorean theorem to find the length of the hypotenuse. And this hypotenuse here, this is the magnitude of the vector. So that means that ax squared plus some ay squared is equal to a squared. And so if we solve for this, we use here our formula. So the absolute value, the magnitude of our vector here, is equal to the square root of ax squared plus ay squared. So that allows us to find the magnitude of the component. Okay, so we have the magnitude, but what is the angle? So to find the angle, we take the inverse tangent of the y component, so a of y here, and divide it by the x component. So we have to be a bit careful here. So this gives us information about the angle, but just to backtrack, the tangent of theta is equal to the y component divided by the x component. That works because for any angle theta, there is an exact ratio between the length of the opposite side divided by the adjacent side. So if we know the angle, then we know this ratio. So the inverse tangent takes this ratio and then gets an angle out. So if you are operating between 0 and 90 degrees, this works great. However, when the angle is between 90 and 360 degrees, we have to be careful about the angle that you get from the finding the inverse tangent on your calculator. But the point here is that if we have the x and y components of a vector, we use our Pythagorean theorem to find the magnitude, and then you go to your calculator and you take the inverse tangent of the y component divided by the x component to get information about the angle. Okay, so we have an example to do. So we have an object that is moving at -7 meters per second in the x direction and 4 meters per second in the y direction. So to solve this, we take the inverse tangent of 4, so that's our y component is 4 meters per second, our x component is -7, and then we plug that into our calculator, and if we do that, what do we get? We get -30 degrees. So, okay, this is a little worrying. So if we go to our graph here and we draw in -30 degrees, it's going to look something like that. So what happened? We know the answer. So the answer is positive in the y direction and negative in the x direction. So it's in quadrant 2, and it needs to be between 90 and 180 degrees. Well, the reason is that the calculator isn't quite as smart as you think it is. So the thing is, if you were finding the inverse tangent of 4 divided by -7, the calculator does the same thing. It also thinks you could be asking for -4 divided by 7. So that's what this thing is. This -30 is -4 y positive 7x. And since your calculator can't tell the difference, it just tells you an angle between -90 and 90. So we have to think about what our answer is by looking at, and figure that out from what our calculator is telling us. So the answer needs to be between 90 and 180 degrees, so we add 180 degrees to the -30, and that then gives us the angle of 150 degrees, and that is the right answer. So yes, that's our angle of 150 degrees. And so this is also going to give us issues in the third quadrant. So there both the x and y components are negative, so you're going to get an angle between 0 and 90, but actually your angle is going to be between 180 and 270. So the best way of doing this is to remember the values of the quadrants. So in quadrant 1, the y value is positive and the x value is positive. In quadrant 2, the y value is positive and the x value is negative. In our quadrant 3, the y value is negative and the x value is negative, and in quadrant 4 here, so there our y value is negative and our x value is positive. So we use this to figure out which quadrant we're in, and then based on that, we use the value from our calculator by adding 180 to get to the appropriate quadrant if necessary. Okay, so let's try the next one. So here we are given that the y component of a velocity is negative 5 meters per second, and the x component is 14 meters per second. So that means we are in the fourth quadrant, right? Our y value is negative, and our x value is positive. So that means our angle here should be between 270 and 360 degrees. So if we find the inverse tangent, so that's going to be the inverse tangent of negative 5 divided by 14, and we do this, and our calculator tells us that this is negative 20 degrees. So we're turning 20 degrees clockwise from the x-axis. So that's actually the right answer, but we are asked for an angle between 0 and 360 degrees. So to do that, we're going to add 360 degrees to our negative 20 to get an angle that is between 0 and 360, right? So if you add 360 degrees to your angle, that's like, just running back around in a circle. You're exactly back where you started. So if you add 360 to an angle, you have the same value that you started with. So if you're in the fourth quadrant here, then you're probably going to want to add 360 to get this appropriate angle. All right, so I wanted to mention this homework question that gives people a lot of trouble. In this problem, we are given that a boat is traveling 20 degrees north of east, and then it turns and travels 40 degrees north of west. So to find the components on the first leg, the magnitude is 20 kilometers, and the angle is 20 degrees north of east. So just like the angle that we find from the x-axis. So it's just going to be, our y component is going to be 20 times the sine of 20, and our x component is going to be 20 times cosine of 20. So then we have our, then the boat turns, and it has a new heading that is 40 degrees north of west. So that means the new displacement is 40 degrees above west in our compass rose. So what's happening here? So our boat has turned, and so now it is traveling along this vector b that is 40 degrees north of west. So how do we do this? So probably the simplest way of doing this is, what we'd really like is, we would like this angle, the angle that is north of east. And so to find this, we are going to turn 180 degrees to get to the west axis, and then it's minus 40 to get to our vector b. So that means our angle here is going to be 180 minus 40, and that's going to be 140 degrees. So then we've got the appropriate angle, and so then we can just solve it the way that you do it. So this isn't the only way to do this problem. So some of you are maybe comfortable with trigonometry, and you can just pick the whichever angle you want and solve it. But I think a lot of us struggle a bit with trigonometry, so we try to make it as consistent as possible, where we're always working from this angle that is counterclockwise from the x-axis. And if we're not given that, then we find that angle, and then we proceed from there. Okay, so you have 2 more questions to do. They shouldn't give you too much trouble, but this concept of finding the magnitude and the angle, especially the angle from the components of the vector, it does give people a good bit of trouble. So we're going to have a bunch of practice on this in the homework. All right, I think that's enough for this week. So next week we're going to start looking at two-dimensional motion. So we're going to get to use these two-dimensional vectors. All right, good luck with your questions, and take care of yourselves.